Okay, welcome back to Web3 Protocol Africa. This is Nanle Nathaniel. So in today's workshop, I want to talk to you about inside Ethereum client, how transaction flow, execute and finalize. How transactions flow, execute and finalize. So the overview, what we'll be expecting in this workshop is, the first thing we'll look at is why this is important. Why are we looking at how transactions flow? Why are we looking at this guy? Why how transactions flow, execute and finalize? We're going to see reasons, and we're going to be seeing what is a transaction, and we're going to be seeing the logic behind the mempool. We're going to see consensus, pick the transaction. So basically this overview is just a flow of how the workshop is going to be like, and then we're going to be looking at the EVM comes alive transaction execution. We're going to be looking at finalize the block, and then we'll take a summary. We're going to be taking a summary of the full pipeline. So like I said in this last line, it's like a pipeline. So these things are in a flow state. So we're going to be explaining these things like a step. So every slide is dependent on the previous slide. So that's how it's going to be. All right. So why is this important? Why is it so important for us to understand the flow of transaction? Why is it so important? The first reason I quote is every app you use on the Ethereum relies on this pipeline. So what we're going to be looking is the life cycle of transactions, from the execution client to the consensus client, how these things will work together. We're going to be seeing how transactions happen. And then we say by learning this, you can build your own client. So like I said in my previous video, one thing I've come to understand when it comes to protocol development is that the writing of the code is not really what's difficult, it's the understanding of the logics. So when you finally understand the flow of how things happen, believe me, to write the code won't take you more than 2 hours, more than 3 hours. But you see, to understand the logic will take you many weeks. You're studying, you're finding materials. So it's very important we know how these things flow. Okay, transactions, where is the transaction starting from? How is it being processed? Okay, so after being processed, where exactly is it going next? So when you understand the flow of this thing, to build your own client is simple. I mean, there's a team, I'm trying to see how I can work with them. They're trying to build the consensus client with Rust. So they have a unique way of implementing their own consensus client. The reason why they can do this is because they've understood the flow of how transaction happen from the execution client down to the consensus client, and the role of beacon chains and validators. So all of these things are very significant. And then one of the things you get to understand after understanding after having a thorough understanding of this flow, this pipeline, is you'll be able to debug smart contract deeply. I mean, you're not just writing smart contract, you're knowing what's happening. And that's one of the things that makes me love protocol. I don't just want to be doing things without really understanding why these things happen. Yeah, it's called critical thinking actually. All right, and then you can contribute to the Ethereum protocol. You can contribute to the Ethereum protocol after having an understanding of how every stage of transaction, you'll be able to know where issues are in protocols. Maybe for instance, if you go to GitHub now, there are all kinds of issues to these clients. So they need people who will be contributing. But you can't, sometimes you just get overwhelmed when you see certain code base. Or if you understand the flow of how transactions happen, you know very well that every protocol is handling transaction. That's just what they are doing. Every protocol is handling transaction. So if you know the flow of this transaction, you can now know how to start tackling these things. The journey is now shortened. You understand how to approach these things. All right, without wasting much of your time. Now, what exactly is transaction? So think of a transaction as a signed message that says send 1E to Alice or run this smart contract. So if you've ever been in exposed to anything blockchain, I mean, you see this example littered everywhere. Ali send 1E to Bob. So all of these Alice sending 1 ETH to Bob, Bob sending 2 ETH to Alice. They are transactions. So for every transaction, it contains certain things that are very significant. Now, what every transaction contains is, it contains the two, meaning who is the beneficiary of this transaction. For instance, Alice is sending 2 ETH to Bob. So what the transaction now will contain is, the transaction now is like a struct that contains details of, yes, just like a struct now. It's like a container that contains the detail of a transaction. Do you understand? Yes. So in the transaction, you have whom you are sending to. I mean, this is very, very elementary. I don't want to stay here for long, but I just want you to understand that every transaction has a tool, the value and the data, and then it has gas limit, gas price, and signature proves it's from you. So all of these things are cryptographics, right? Yeah. So that's the idea behind transaction. So I want you to see it as Alice sending 1 ETH to Bob. I'm sending 1 ETH to Alice. Just picture it as simple as it is. That's what it involves when it comes to transaction. Now look at this. Now Alice wants to send 1 ETH to Bob. Alice has a wallet. So all the transaction that she's doing is actually starting from her wallet. So wallet is now having access to the execution client. Are we together? I know we're together. So your wallet signs a transaction and send it to a computer running Ethereum software. I'm starting this way so that we can understand the context. So your wallet signs a transaction and send it to a computer running Ethereum software. Now, this software is called an execution client. This software is called an execution client. So when your wallet signs, if you want to perform a transaction, to those of you who are exposed to Web3, you are using your wallet and you want to sign to a transaction, I mean, there's going to be a pop-up that requires you to sign, right? So what that is happening is that you are accessing the execution client. Remember, we have the execution client and we have the consensus client. So this is how we now start making use of the execution client. So when you sign, when a transaction is about to happen, you are accessing the execution client. Now, what does this execution client do? It's important you know this. So what does the execution client do? The first thing it does is that it checks the signature validation. It checks the signature. Okay, this person who is signing this transaction, is he the real owner of this wallet? Is he the one from just what I showed you here? Signature proves it is from you, right? All right. And then the next thing it does is, does the sender have enough ETH? So Alice cannot send 1 ETH when all the ETH in our wallet is 0.2. It's not going to be possible. And then the next thing it does is the transaction well formed? Is the transaction well formed? So every transaction has a template. Now the reason why I don't want to dwell here is because the emphasis is not just to see the details behind a transaction. I want to show you the flow. The flow. So what we've seen thus far is that your wallet signs and access a computer running Ethereum software, and that computer running Ethereum software that your wallet signs to is the execution client. And there are certain things the execution client does. It signs to validate, and then does the sender have enough ETH is trying to send for that transaction, and then is the transaction well formed? Now after all of these things are tick checked, the next thing is that if yes, it puts the transaction in a place we call the mempool. In a place we call the mempool. I'm going to show you some code snippet where I explain these logics to you very, very well. So when the transaction is signed from the execution client, the next thing it does is that it stores this transaction in a place we call it the mempool. And you can call it the waiting room for easy reference. Now you see this mempool. Now the next slide, execution client puts incoming valid transaction into a mempool. So after the execution client first of all checks if Alice has the proper amount of ETH she's having intention to send to Bob. Maybe let's say, like I explained earlier on, it first of all checks if Alice has the 2 ETH she's trying to send to Bob. If she does not have 2 ETH, then the transaction is considered invalid. So all the transactions that are stored in the mempool are transactions that the execution client and successfully validates. So you see this place called mempool. Now you're now understanding from whence transaction is coming from and why they are stored in the mempool. You look at all of these things such that when you start building your own mempool, you want to write the code for mempool, you won't be overwhelmed because you literally have an idea of how transaction flow. If I carry you now and take you to the execution client, you open the code base, any code base at all that involve the execution client, you won't be overwhelmed because the first thing you are checking now is the transaction flow. All right, I know wallet is signed. The next thing you check is, okay, how does the execution client communicate with my wallet? You are checking these things. You are checking these things from the code base and you're understanding it. Simple as that. So when transactions are validated from the execution client, the next thing it does is that it stores those validated transactions in a place we call the mempool. So I have a code snippet that does that. This is just a very quick snippet of the code. Now let's say, and this is with Rust. So let's say this is a struct containing a vector of mempool. Now this vector contains the list of all the transactions that are stored in the mempool. I'm implementing this. So I have a function that adds transactions. A function that adds transactions and then pushed my transactions inside the mempool. That's what it's doing. And then when you push inside, these transactions are stored as pending. So you can actually call this function the get pending function to see the list of transactions that are still on pending. Are you getting this? I know you are getting this. I know you are getting this. So what we've seen thus far is that transactions are signed with our wallets. The execution clients validate those transactions if the person who is trying to execute this transaction is actually the right person, and if he has the amount of it required to execute that transaction. And then after the execution client has successfully validated that transaction, it sends those transactions to the mempool. So this is the function that adds all the transactions that are validated from the execution clients. So this function, what this function does is that it takes transactions and then push transactions to our mempool. Yes, and then this function, when you call this function, you're calling the list of all the pending transactions that we have. So transaction sits here until it is time to produce a block. So like I said from the very beginning of this workshop, I told you that every slide is a correlation of the next slide. So now we are seeing that our transactions are stored temporarily in a place we call the mempool. And now we are also seeing that transactions sit here until it is time to produce a block. So let's see what that means. All right. Now we have the concept of the consensus client. Now what the consensus client does is that the consensus client picks the transactions. Now validators propose blocks every 12 seconds in Ethereum proof of stake. So what that is telling you is this. So when the consensus client picks a block, what that block does is that it gets the transactions that are stored in the mempool. That's what it does. So the consensus client fetches transactions from the mempool. Are you now seeing that we are leaving the execution client and we are connecting to the consensus client? So from the execution client, transactions are stored in the mempool. But to take it further, the consensus client now takes those pending transactions from the mempool when blocks are created. It's very important you understand this. And the logic with which validators propose new blocks so that transactions can be added in those blocks is the mechanism we call the proof of stake. That's not our emphasis. Our emphasis is to understand the flow. Next slide. All right. So this is the code snippet. Now we have a function that proposed block, right? Yes. Now this is a validator that is selected proposed a block. Now when the validator successfully proposed a block, this is the block variable. It's mapped through our mempool and gets the pending transactions in the mempool. After a block is created, yes, by a validator, the next thing it does is that it maps through the pending transactions that are in the mempool When it gets those transactions, what it does to those transactions is that it sends them to the next state. So what this function does is that it adds them to the block. So transactions that are stored on the mempool are the proposed block. After creating a block, it maps through the list of all the transactions that are stored, and then it stores them in the block that was created by the validator that was choosing to propose a new block. So the proposed block, transactions that were once stored in the mempool, the pending right? Yes, they are now added to the block. So a new block is created from the mempool. It's amazing. All right, so the EVM comes alive. Now you need to pay attention to this. There are moments where you use your wallet, you do a transaction, it's signed successfully, but the other person is yet to get the amount of it you are sending to him. The reason why that person is yet to get it is because your transaction was stored in the mempool. So when a validator proposed a new block, and then the transactions that were stored in the mempool, now are gotten from there and they are added to the block. When the transactions are added to the block, what the EVM does now, the EVM is now in the execution client. Now the EVM comes alive because the consensus clients are now attesting to the fact that, okay, this transaction is legit, we are good to process it. So this is when the smart contracts start to play, such that the person's address that you placed on your wallet, now the transaction is happening. So whatsoever is happening after that point is your smart contract. This is where the smart contract logic is run. So the EVM execute instructions like push, add, call, and store. I mean, we have videos. I think we have a tutorial on the EVM. I think I'll suggest, okay, I need to upload that video. I will upload that video very soon. We have videos regarding the EVM. So that will do justice to that. But like I said earlier on, what I'm trying to achieve here is so that you can get to understand the flow of transactions, such that you will now begin to appreciate every component that are involved in the consensus and the execution client. Yes. So when the validator proposed a new block, transactions are added to that block. So when those transactions are to be added to the block, the EVM now comes to play. So the smart contract start to execute its logic. Okay, transactions that are stored in the mempool, come out, let's execute you. When it executes them, let's see what comes next. All right, so this is the code snippet. This is a code snippet for execute transactions. This is my EVM, and then this is my code, right? So what my EVM does is that it takes the transactions and executes them. This is plain and clear and as simple as you can ever imagine. Don't worry, I have a tutorial for the EVM, Ethereum Virtual Machine, that will explain these logics to you guys very, very well. The next one. Now, after the EVM had successfully executed that transaction, the transactions that are to be added to the block, what we call it is the finalize the block. Now, the consensus client helps broadcast and finalize the block. Get enough validators to agree it is valid. So remember what we said. We said after the transactions are stored in the mempool, a validator propose a new block, and in every block that is proposed, there are transactions that are stored on that block. Those transactions are gotten from the mempool. That's transactions that are on pending, right? Yes. So after this validator has successfully add all the transactions stored on the block, they don't just automatically place them as part of the blockchain. What it does now is the concept of the proof of stake, where we have many validators within the consensus client. They will now need to agree that, okay, this block that this guy is proposing to us is actually valid, is actually genuine, so let's add it to the blockchain space. So when the validator successful, when all the validators come to agreement to that block, they add it to the blockchain. Now that is called finalizing the block. At that point, there's nothing you can do again. Your transaction is gone, is there on the blockchain forever. So the consensus client help broadcast and finalize the block. get enough validators to agree it is valid. So this is a code snippet. Finalize the block. It gets the block, gets the state. So what it does is, like every other block that is added on the blockchain, there's a hash attached to it. Yes. And then save block to chain, update canonical chain. So there is a list of previous blocks on the blockchain. So you are updating the list of the blockchain. And I want to be very sincere with you guys. When I actually started this thing, canonical chain is just complicated. One day I will dedicate a full video to explain this canonical chain for you guys. So all of these things now, this is a general overview of the transaction flow, such that when we start to break these things into smaller units, we start to explain update. When we start to explain the logic behind updating canonical chain, it won't be strange, because you know from whence this thing is coming from. You know that for we to even say we want to update canonical chain is because the validators that are involved in the consensus, they've come into a mutual agreement to the block that was proposed by a validator. So all of them had come into a mutual agreement, a consensus. That's the right word to use. Yes. So in summary, this is what is happening. In summary, this is what is happening. Now, this is the pipeline. The first thing is user sends a transaction, right? And then he calls to validate transaction within our execution client. And then transactions that are validated by the execution client are stored temporarily in a place we call the mempool. All of these things are still within the execution client. And then the next thing is block production. Proposed a block. Now this is when we now start to involve the consensus client. Now a validator is selected to propose a new block. And now when a validator comes and proposes a new block, for transactions that are stored within the mempool to be added to this block, the EVM now will need to now execute those transactions so that they can be added to the block that is now proposed. And that's when you start to involve all the opcodes. You will see all of these things. We've done a video involving all of these things. Like I said earlier on, we'll upload it and you will see these things. So when the EVM successfully execute these transactions, so before the block that now contains the current transactions to be added to the blockchain, it needs to be finalized. And we've explained the concept of finalization. It is a concept where all the validators come and they come into a consensus that the block that is now proposed by this validator and the transactions added on the block is legit. If they all come into a consensus, a mutual agreement, then the new block that was initially proposed will now be added to the block. At this point, there is nothing you can do again. Now, when you understand the flow of this thing, you will know when people are saying there's a bug happening, and the bug is that the consensus client is not finalizing block. Now you know what it means. Now you know what it means. I'm doing this tutorial out of frustration. I'm going to be very plain to you guys, because like I said earlier on, one of the things that seems very complicated when it comes to protocol development is the idea. When you can understand the idea, believe me, to write the code is not very complex. It's not very complex. All right, after seeing all of this, I want to now take you through why it's important to know the flow. Initially I said that, but I want to now read it so that now you can appreciate it. So the reason why we need to understand this pipeline, this flow, is so that we can be able to build our own consensus or the execution client. How will you start building the execution client or the consensus client when you don't know the life cycle of transactions, where transactions go, what happened to them after getting to this point, what happened after next, and how are they finalized? If you don't know this thing, there's nothing you can do. And the next thing is to debug smart contract deeply. So when smart contracts are having issues, you know exactly where the issue is. You know the EVM. Go straight to that place. And then you can contribute to the Ethereum protocol. I told you guys there's a consensus client written in Rust. I'm trying to see how I can contribute. They're just starting up. I'm trying to see how I can also contribute to see that this consensus client comes into fruition. It's called the RIM. Maybe they may be watching this video. I'm actually advertising their projects. Yeah, so it's a consensus client that was written with Rust. So having understand these things now, you know very well that this is the rule of the consensus client. Okay, there's a point where the consensus client take 12 seconds to propose a new block. So when you go to your code base now, you know what you are looking for. You know exactly what you're looking for, straight to the point. When somebody tells you, okay, our consensus client is not working the way it should, and you ask them, what's the problem? And they tell you that, okay, our block is not proposing 12 seconds, our own is proposing 1 hour. You know exactly what to do because you've understood the flow. You've understood the pipeline, the life cycle of transactions within the Ethereum client. It's just amazing. Just amazing. So this is the end of this workshop for today. If you have any question, please reach out to us on Twitter. Our Twitter handle is Web3 Protocol Africa. We're really looking forward to reach out to you. Web3 Protocol Africa. And my Twitter handle is @nanle_. I'm really looking forward to meet you guys so that we can collaborate and work with some few projects and all of that. So see you in the next